Okay, so as promised, I was supposed to make a video on question number 5 for the randomized tutorial. Let me just get the pen working. Okay, the pen's working. Alright, okay, so please pardon the bad handwriting. I also don't know why it sounds so formal. Anyway, let's begin. So this is question 5, and I'll give the context or the background. But please, I'm pretty sure that you should have at least like attempted the tutorial by yourself first, or in your own respective tutorial classes or mine, right? But I'll just explain some of the context behind the question. Okay, so we're hashing n items, right? Hashing n items, okay, into a table of size m. Alright, and we're given, right, we're promised that the probability, right, that two distinct items, let's call them x and y, so h of x and h of y, the probability that these are the same, right, is at most 1 over m. Alright, so hinging on the fact that x is not equals to y. Okay, so we're hashing n items into a table of size m, right, and we want to count the number of items in each slot. Okay, so nj is the random variable. Okay, so this is a random variable, right, that counts the number of items that hash into slot j. Okay, so in some sense, what we're saying is that let me just change back to the pen. What we're saying here is that this is actually just the same thing as the number of items, let's say x, such that the hash of x is equals to j. Alright, okay, so hope you follow so far. I'm pretty sure it's nothing advanced yet. Okay, so I need to erase some of this stuff, right? This is important. Okay, this is important. What else is important? Well, this is kind of important. Well, I would like to keep the problem statement on the screen, but some of this is going to be erased. So if you want to, also this is okay. There we go. So if I'm going to erase it. So if you want, just like write this down or something. Or actually no. I'll tell you what. I won't erase it. I'll just move. Oh, like maybe down here. Okay, right. So, and I'll just repeat that we want to show that the expectation of the sum of j is equals to 1 until m, and j squared is equals to, oh wait, less than or equals to n times 1 plus alpha. Alright, but whatever definitions I have here, alright, I'll go back to them later, but we're just going to move them out of the screen. Okay, and you should be familiar with them by now. Oh, actually I don't have a lot of space anyway, so yeah, I'll erase when I need to. Okay, so let's begin. We know that this is a random variable, right, that counts this. So let's just expand it into the definition that we're given. Okay, so we know that nj, right, is equals to, we're going through all the items, right, I is equals to 1 until n, going through all the items. Okay, and then we're going to ask them, hey, did you hash into slot j? Okay, so let's just call that xij. Okay, so this guy, okay, he's defined as an indicator random variable because it can only take on 2 values, right? And it takes on 1, okay, if the h of I is equals to j. Alright, likewise over here, okay, it's 0 otherwise, right? So if h of I is not equals to j, you can only have these two possibilities, right? You can't have something in between. Okay, so in this case, this is just by definition, right? So let me explain. If you already understand why, you can skip ahead. If not, if you don't understand why, or if you'd like to be sure, I'll explain it now. I can't tell you which time it will turn out to be, so just, yeah, whatever, skip ahead to like binary search or something until yeah, okay, I'm wasting time. Anyway, think about it this way. This is a random variable, right? So this can take on arbitrary values, and it's based like like it's randomized, right? So when we want to count the number of items that hash into the j slot, right? It's like setting an indicator random variable for every item. So let's say you have n items, right? So item 1, item 2, item 3 until item n, right? So for each of these, you set an indicator random variable, right? So x1j, x2j, x3j, so on and so forth until xnj, right? And each of these, right? If let's say that this guy hashes to j, right? So the hash of this guy goes into j, right? Then this guy is equals to 1. Okay, if the hash of this is not equals to j, so if it's something else, we set this to be equals to 0. Alright, so this is how we're counting. Remember, indicator random variables are useful for counting, right? Okay, so this is the part I run out of space, and now I need to like erase. So let me just fiddle a bit, move back up here. Okay, I hope you've written it down because I'm about to erase it now. Okay, need a bit more. Why? Okay, this works. So this also works. Yay! Cool. Just give me a bit of time. Actually, I can increase the eraser size. There we go. Okay, let's get rid of this, all of this, since I need the space. Okay, great. Okay, so to recap, we have that definition, right? That nj is equals to, from all n items, oops, okay, from all n items, right, we have xi, ooh, that's not I. Okay, so xi, j, right? Now we don't really want nj squared. It's quite useless right now. What we want is sorry, we don't want nj, we want nj squared, right? So this is quite useless to us right now. We need to square it, right? So let's square it. So if we square it, right? So nj squared, right? By our definition, right, would be equals to this thing squared, the entire thing squared. Oh, mistake. There we go. There. Right, so this would be equals to xij squared. Okay, and I hope I don't need to convince you anymore why this nj is equals to xij. Okay, I mean we're just counting. It's like coupon collector. You're like counting, right? Yeah. Okay, so we square this, right? And if you think about it, right, when you're squaring this, j is fixed, right? And we're parameterizing across all the i's, right? So for those of you who didn't get it, let me just go into detail, right? For those of you who do, I'm sorry, but I feel like this is quite important, so I'm just going to go through it anyway. Think about it this way. When I have nj squared, right, okay, so it's like summing this squared, right? So it's like x1j plus x2j plus so on and so forth until xnj squared, right? So what does this come down to? So this is like taking the first guy. Okay, let me just expand this so that it's a bit more visual. 2j, same thing, xnj times x1j plus x2j, xnj, right? Okay, so think about it. When you're doing this multiplication, right? Okay, it's like this guy, the first guy, right? This guy, it's like taking him and multiplying with this guy, so on and so forth, and this guy, right? So you end up getting something like xij times x1j times x1j plus x2j x1, sorry, my bad, x1j times x2j plus x1j times x3j, so on and so forth until x1j 1j times xnj, right? Now you repeat this for everything, right? So you don't just do it for the first guy, you do it for the second guy, so on and so forth, right? So you have like this, you have the x2j plus x1j plus excuse me, x2j plus x2j plus x2j, x3j, right? So on and so forth. And I hope you spot the pattern now. Okay, xnj. All right. So let's say on this row you have the x1j's, on this row you have the x2j's, and this is not a proof, right? I'm just showing you the pattern here, right? and on the last row you get x and j. So we get like x and j here time. This wasn't supposed to be a plus. This was supposed to be a multiply, right? So this here is a multiply. X 1j, right? X and j times x2j. I hope you haven't fallen asleep yet. And then this becomes x and j times x and j, right? Okay, so what was the point of me trying to bring this up, right? I need more space. Give me 1 second. Okay, and I need to erase this. So let me just get the pen out. Nice. Okay, and be faster if I can just. There we go. Okay. So what was the point of me bringing this up? It's because if you think about it, right, I want to break this sum into two very manageable portions. Okay, I mean they all sum to the same thing. It's just that it'll be easier to analyze it that way. Okay, so what I'm going to do is I'm going to rearrange the sum. Since we're summing across everything, right, we can change the ordering, right? I want to break this into two sums. Instead of summing it like this, what I want to do is I want to take all the squares out. So this is a square, right? Or maybe I should use a different color. Let's use yellow. Okay, there we go. Can I undo that? Oh, I can. Okay, so we want to take these. Right? Oh, yeah. So this is a 2. This is a 2. Okay, and then let me just write this down. X3j times x3j. Okay, I want to take this, right? All the squares, right? All these, right? Put and sum them up together. So this is the same. Oh, yeah, fine. I'll just use yellow, right, to indicate the next step. This should be the same as summing up all the squares. So the squares, right? The squares, I sum them from I is equals to 1 again until n, right? X I j squared, right? Now I take the rest. Okay, so let's use a different color for the rest. I feel like using green. Let's use green, right? So I take the rest, which are all of these, right? Oh, bad lining. Okay, these, right? And I'll take these. Okay, so of course all the remaining pairs that I'm taking, right? The remaining pairs that I'm taking are all the ones where the first number on each subscript are different, right? If you don't follow, like just scroll back a bit and you realize that we've taken the ones where they're the same, so the only ones remaining are the ones that are different, right? Okay, I know in class I did like I naught equals to j, but let's do it in two sums here, so that way it's a bit clearer, right? Let's say I'm running out of indices. I will use I and then k. Okay, so like let's say we're summing from I equals to 1 until, what am I summing till? I'm summing till n, right? Times I equals to sorry, not I can't use I again. Oh, don't want to erase that much. Go back. Okay, and we're going to use k, right? Not equals to I until n. Okay, this isn't exactly valid notation. What I mean by this is that k can take on values from 1 to n as long as it's not equals to I. Alright, this is abuse of notation. I hope you get the point. Okay, so then you do xi j times x, what was it again? Kj. There you go. Alright, so if you think about it, right, okay, this sum right covers 1j, so like 1j times 2j, 1j times 3j, 1j times nj, so on and so forth, right? This one covers 2 times 1j, right? 2 times 3j, 2 until nj, right? These are all the different ones, right? Okay, so then I need to do a bit of an observation here. Okay, let me just move that out of the way and delete the rest of this. And I don't know how to increase the size of the canvas, so there'll be quite a fair bit of erasing going on. Also, I tried zooming in a lot more, but the size of the pencil like loses resolution. I mean, because it's like the smallest I could go. So okay, whatever. We're moving on. So let me just go back to like blue. Let's say I don't even know if it's the same blue. Oh, it's not. Okay, this should be close enough. Okay, so excuse me. Let's deal with this guy first. Okay, so if you think about it, right now, right, what am I doing? I'm summing all the pairs that are not the same, right? Okay, if I'm summing all the pairs that are not the same, right, it's like summing all the pairs that are not the same. Okay, so because I have that x, let's say ij x times xkj, right, is equals to xkj times xij, right? So every distinct pair, right, okay, is repeated twice. Okay, so what that means is right, something like x, you're gonna see like a x1j times x2j, let's say, right? You're gonna see that once, and then you're gonna see that again as x2j times x1j, right? So these are repeated twice. Okay, so what that means is, right, okay, I can actually simplify this sum, right? I consider all distinct pairs, okay, I consider all distinct pairs and multiply that by 2, right? Because all distinct pairs, so this is like a distinct pair, right? If all distinct pairs are repeated twice, I can multiply it by 2. Yes? Okay. So this, right? Think about it this way. This is all distinct pairs, and I need to start making an observation here. Okay. We'll do that first. Okay. So this is observation number 1. Let me label it as #1. Okay. We need observation number 2. So let's think about number 2 now. Okay. So I need more space. Let's get rid of this first. Okay. And I'll be erasing this later for more space. So if you want, write it down. If not, try to remember it. Okay. So observation number 2. Okay. What is the value of xij times xkj? Like these both take ones or zeros, right? These both take ones or zeros, right? Which means that they can only take on 2 possible values when you multiply them. They can either only take on 1 or they can only take on 0. Okay. When do they take on 1? They take on 1, right? They take on 1 when the ith item hashes to the jth slot, right? And when the kth item hashes to the jth slot, right? So both of them hash to j, right? So this is h of I is equals to j, right? And h of k is equals to j. Okay. Now at this point, right, it might be tempting for you to say that can we simplify this, right? Like you might be wondering, can I simplify this and simply write h of I is equals to h of k, right? And the answer is no, you can't, right? Because we're fixing it on a specific value j, right? The probabilities turn out to be different. Okay, I'll leave that as a small exercise for you guys to figure out why. Okay. If you're still unsure, you can text me, or well, I hope it's apparent by now. Okay. So think of it this way: these two take on 1 when they both hash to j. Okay, and they take on 0 when either of them don't. Right? Because if one of them is 0 and this one is 1, you still get 0. Right? If this one was 0 and this one is 1, you still get 0. Right? The only way you get 1 is if both of them hash to the j slot. Right? Not just the same slot, not just any slot and the same, but it must be j, right? So that's observation number 2. Okay, we'll need that for later. We'll also need this for later. Okay, so let me just get rid of this. Erase. Okay, so that's what we have here. Okay, now let's move on to this side. Okay, this side, if I have xij squared, right? When is this one? This is one when, I mean, okay, think about it this way. This can only take on 2 values as well, 0 or 1, right? And it's based off the same reasoning. The same reasoning being, okay, these are the same, right? So when xij is equals to 1, right? Clearly, this implies that xij squared is equals to 1, right? And when xij is equals to 0, right? Then xij squared is equals to 0. Right? And remember, these unindependent events, you're not doing xij, you're not like trying to sample from xij twice. You're only sampling once and then squaring the value, right? So whatever probability, right, that xij takes 1, with the same probability, xij squared takes 1. Right? Okay. Likewise, the same logic, xij, right, when it takes 0, with whatever probability it takes 0, xij squared also takes 0. Alright? Remember, this seems counterintuitive, or like at least when I learned it, right, it seemed like you're sampling twice. You're not sampling twice, you're sampling once, then squaring the value, right? So since you get 1 with probability, let's say p, right, you should just square and get p as well. All right, so these are the key things that we need, right? These are the key things that we need to finish it. Let me just get the larger eraser so that way it saves time. Get rid of this, get rid of this, get rid of this, get rid of this. Right? Okay. Oops. Okay. So remember that this was nj squared, right? Now we want the expectation of nj squared. Yes, the expectation of nj squared. So what that means, right? Oh no, we don't just want the expectation of nj squared. We want the expectation across, like summed across all the j's, right? From 1 until m of nj squared, right? But we have, get rid of smaller eraser size. There we go. Okay. But what we have right now here is nj squared, right? Okay. So let's apply the summation first. For that, I need more space, so I'm going to move up. Okay. So at this point, I give you like maybe a few seconds to just pause the video, right, and copy this out somewhere because I don't have much space left, right? So this is what we have for nj squared. Okay, and I hope that you've been following up till now, because I think I'm going pretty slow and I'm really going to detail, right? So to summarize, I've explained what values these can be, right? This can be either 0 if either of these are 0, right, or 1 when both of these are 1. Okay, and for this guy, right, this guy, he takes 1, it takes 0 with the same probability that xij itself, the non-squared version, takes 0, and likewise for the 1, right? So at this point, right, I should probably say something. This, right, if you think about it, it takes 1 with the same probability as the non-squared version, and it takes 0 with the same probability as the non-squared version as well. Okay, so what that means, right, is that xij squared is actually just xij. Okay, you can't say this in general, right? So like if like xij was like, let's say it takes like 2 and 0 with probability p and probability 1 minus p, you can't say that they are the same, right? Because in this case, right, xij squared would take on 4 with probability p and 0 with probability 1 minus p. Alright? The reason why we can say this is because this only takes a value of 0 and 1, so this only takes a value of 0 and 1. Okay? Okay, so let me just erase this. This is not important anymore, right? Get rid of this. Okay? Okay, so this guy, right, this guy is equals to xij. Okay, so oh, I guess I should just say that we can cancel out. Yeah, there you go. Okay, so this is a summation. This is a summation. I'm not sure if you can see the cursor. I might have removed it. So let me just use a different color. So this, right, is the summation that we've come down to, right, from for nj squared. Okay. Okay, great. Like I said, keep this on a piece of paper somewhere. I need to like clear out the entire thing because right now I need more space. Right? Okay. So I'm just gonna delete the layer. Can I delete the layer? Delete current layer. Yes. Okay, add new layer. Great. Okay, now let me just move so that I have more space. Let me just go back up. Oh, around here. Okay, great. Now, okay, let's summarize. We have nj squared is equals to the sum of what was it again? I is equals to 1, right? Until n x. Oh, I guess you didn't have to write it on a piece of paper after all. Oops, my bad. Okay, squared plus summation of, what was it? I is equals to 1 until n, sum across all k, right? Not equals to I, n squared? Sorry, n, yes. Xij times x k kj, right? Okay. Nice, we're like working across all the colors. I actually like this color. This color looks nice. Okay. Now we're gonna relate this back to expectation of j is equals to 1 until m and j squared, right? Okay, let's work across the sum first, because remember, we can apply linearity later on, right? So if I were to try to linearize this, right, if I'll try to let's just very faintly write an e here. If I try to e this, It'll be the same as E-ing this. It'll be the same as getting an E on this. Okay. Do note one thing: linearity of expectation, right? This does not always imply that E of xij does not imply that these are the same thing, right? You don't always have this. Let me just get this guy out. Xkj. Okay, you don't always have this, right? So this in general is not the same as this. Okay, and if you want, you can show that this holds, like this holds if they are independent, right? So as in equals if independent, right? Else it doesn't hold. Okay, it's a simple exercise in probability, so you can go find out more about that here. I'm just mentioning it because I don't want you to make this mistake during the midterms, right? If you see the product of two variables and you find it convenient to do this, you need to make sure that they are independent. All right. So don't make the mistake of thinking that these two are the same. They're not always the same. Okay. Okay, let me erase this because I need the space. Sorry if the video is long-winded, by the way. Yeah. Okay, so we want, let's deal with this guy first. Let's just deal with the summation first. Okay, so the sum, right, of this guy across this guy is just by applying definition, the sum across j is equals to 1 until m, this entire thing, right? So m I is equals to 1 and xij squared plus summation, the two summations again. Wow, my arm is actually getting tired. Okay, I'm running out of space. Oh wait, no, I can do this. I can do this. I'm a professional. Okay. Okay. Excuse me. Xij times xkj, right? Okay. Since these are separate sums, right? Since this is a separate sum, this is a separate sum, right? And we can definitely split this up into two sums, right? Think about it this way. If I'm adding across the terms like this, right, I could have just like added them separately, right? So I can break this down. J is equals to 1, m, j is equals to I is equals to 1, and xij squared plus this guy, k not equals to I, and xij times xkj. Okay, I need more space, so let's go here. Okay, now you see this, the same thing applies. You can't always say this, you can't always swap the ordering around, right? But in this case I can, because if I'm fixing a j and adding all the i's, right, then after that I increment the j and add all the i's again, right? Wait, sorry, we like I previously mentioned, we don't need the square anymore, so let me just erase this. Okay, let me erase this, right? Okay, so and this one as well, so that we know where we're standing. Okay, so right, if I'm adding, like if I'm fixing a j and adding all the i's, then right, then repeating that process, right, it's like swapping the two for loops around. In that case, it still kind of makes sense, right? Please don't take this to mean that it makes sense in general, right? There can be cases where it doesn't make sense, like if there are like negative values in here or something, right? So you need to be really sure before you do it, right? So just think of it as two for loops. If you can swap them around, you can swap these around. Okay, so let's just swap that around right now, right? Actually, do I? No, okay, no. For this one, right? Let's not swap it around. It makes more sense to not swap it around. Okay, so I want to make it simple. I mean, I get that the sum is difficult, but I want to sort of simplify this. Try to figure out. You can pause the video now and try to figure out what this summation is. Right? It should look familiar to you. Okay? It should look familiar to you. So you just pause and maybe like think about it for a few seconds. Okay? So I'm gonna assume you pause now. Okay, so like then I don't wait, and I assume that you've already paused or thought about it, or you don't have to, right? But xij, right? If I'm summing from 1 to n, what is this? It looks familiar, right? This is just nj, right? Because I went around and I asked everyone, okay, did you hash at the j slot, right? So this nj, right? Okay, and I can simplify this even further. Okay, if you think about it, what is this guy? I'm going around to every slot and I'm asking them, how many slots, like, hey, j slot, how many items hash to you, right? and I'm doing this across all the m slots that I can hash into, right? So if you think about it, I tried to hash n items, right? I tried to hash n items, okay, and I added all of them up, right? I went through all the slots and added all of them up, right? So since I hashed n items and I went through all the slots and I counted them, they should all just sum up to n. Make sense? Right? If you don't get it, try to reverse the video and like get the explanation again, because I don't think I can find a different way to explain it, and I don't really want to draw it pictorially because my arm is really tired right now. Okay, right? So I hope you do get it. But if you don't, just text me and then I'll try harder to like find a different way to explain it. Okay. Now for this guy, right? Oh, I kind of forgot to make a sum here. Okay, so let me just, yeah, see, I distributed the sum, right? So one sum comes down here, right? I need another one here. So I also need space. So let me just shift this a bit so that there's more space. All right. So xij plus summation of j is equals to 1 until m, and then j is equals to, what is this? This is I is equals to 1 until n. Okay, great. Now in this case, if you think about it, again, what I can do is I can try to shift this guy inside. I can shift this sum inside. Okay, there is a reason for this. I know in the tutorial I actually broke this down first before summing it across all of the possible values, but you might not be able to do that because our guarantee, recall, which I will write in red now, okay, recall that all I'm guaranteed is that the probability x not equals to y, h of x, right, is equals to h of y, right, is less than 1 over m. Okay, this right says nothing about the probability. This is not the same statement as the probability of h of x is equals to h of y, and x okay, and h of x equals to, let's say, some specific value j, and h of y is equals to some specific value j is less than or equals to 1 over m. Ran out of space. Whoop! What happened? I seem to have moved out of, there we go. Sorry about that. Oh, I need to move this back a bit more. Okay, great. I didn't give this statement, right? This statement doesn't give the same guarantee as this being less than or equals to 1 over m squared. Okay, so I said in the tutorial, and I should apologize, I did make that mistake, right? These are not the same statements. Okay, so bear that in mind. So be really careful about your definitions. Okay, I'm gonna erase this. Also, I'm really sorry to the 9 AM tutorial class. I probably should have come prepared instead of trying to solve it on the spot. So I'm pretty sure by now you can see where I made the mistake. If not, that's great. No one caught my mistake, but I'm pretty sure some of you do. So yeah, trying to fix it now. Okay, let me go back to the same color that I was using. I really like that color. Oh, I could dropper it, I guess, but nah. I'll get as close as possible. Let's see, is this the same color? Yeah, okay, cool. Okay, so again, the same idea, right? If I'm summing one way, I can just change the direction in which I'm summing it. Okay, so trust me on this. I can shift this inside. Okay, so this is the same as I is not equal I equals to 1. Excuse me. This guy move all the way in, so k not equals to I, and j 1 m x I j x h j. Okay, great. So think about it. This guy now, right, actually falls under our definition. We're going around to every slot and we're asking them, hey, slot J, do you have I and K, both I and K in your slot, right? Since you're doing it across all of them, it's like asking what's the probability that they are the same, what's the event that they are the same, right? Because remember this, in this case, right, you're like asking that they slot to J, this guy slots to J, right? And then K and I slot to J, right? And both of them like are only equals to 1, right? You're going across all of them. So now our definition applies, right? If about the previous point of contention, the one that I wrote in red, if you disagree, there might be good reason to. I'm not very sure myself. So I just want to be safe and make sure that the definition applies, right? Okay. They could very well be the same. I just want to be safe. Okay, so let's change. Okay, yeah. So this guy now, okay, is kind of like a new variable. K not equals to j, and let's call that yij, right? Where this is the event, right? With probability 1, with value 1, if h of I is equals to h of k, right? 0 otherwise. Okay, with me so far? Alright. So to summarize, right? I've broken out whatever the nj squared was, right? I've like over here, right? As in I've broken out what this guy is over here, right? I'm simply applying a summation and I'm distributing that summation across the two terms that I've had, right? I've explained how you can use this, right, to get this by definition, right? And how this, right, becomes this, and I've explained how with this triple nested summation I now redefine it, right, this block here into this guy, right? Make sense? Okay, now I'm gonna keep this one because I don't remember, or at least I can't remember it, so I'm just gonna erase the top portion. Okay, I mean, well, for you it's fine because you can rewind and rewatch, but I need to get rid of this because I need the space. Okay, so I'm gonna just hinge off this line and write from above again. Okay, so let me just cut this off. Okay, let's go. Okay, so we have this. Okay, now we want to apply expectation, right? We want to apply expectation. So in other words, let me just go back a bit here. Yeah, we want expectation. Holy shit, this is actually pretty cool. I mean, well, actually no, that's wrong. No, it'd be really cool if this was correct. As in, I was hoping that this would say, I was really hoping that this was going to be expectation across all j m1. Oh, press the wrong button there. Go away. Yeah, there you go. I was really hoping that this was actually, instead of like just nj squared, but like this thing, right? Okay, we want to apply expectation, right? So, oh, I don't have space, right? So if I were to apply expectation on this entire thing, right? If I were to apply expectation on this entire thing, linearity of expectation tells me what? It tells me, right? Let me just E here. Oh, bad handwriting. Okay, this, right, is the same as, j is equals to 1 m expected of nj squared. Yes? Okay. And this was sum of e and j is equals to 1 until m and j squared, right? Right? Okay, so this was obtained previously, right? Now, the expectation of this, right, is just the expectation of this, right? So, so the expectation of this, right, is the expectation of this plus the expectation of this. Make sense so far? I'm just using definitions of linearity of expectation. Oh, I really like that green color I got just now, like that turquoise. I think it's like brown. Yeah, okay. Okay, so applying expectation on the entire sum. Oh, okay, I'm not gonna move. I'm too lazy. The expectation on the entire sum, right, is the expectation of all the nj squareds. Okay, so that is the expectation on n, is the expectation on this guy. Okay, with me so far? Now, expectation on n is not even a random variable. This n is constant, right? I mean, nj is a random variable, right? Because there was some probability hinging on that. Like this, the value hinges on some probability, but n is always n. It's a fixed constant, right? So this is always n. Okay, as in, because this guy only takes one value, right? Nj's can take multiple values. This guy can only take one value. So expectation of n is still equals to n. Okay. Now, what is this guy? This guy is an indicator random variable, right? So we gotta ask ourselves, what is the probability that hi is equals to hk, right? And I hope you remember that based on our definitions, right? Okay, so yij, right, is equals to 1, okay, with probability at most 1 over m, because this was based off our hashing guarantee, right? So this is at most 1 over m, right? 0 otherwise, which is m minus 1 over m. Make sense? Okay. This was just based off the previous definition that I had erased. I written it around somewhere around the top. Okay. So remember, like as I always say, right? This is just equals to the probability that it's 1. So this is at most 1 over m, right? Excuse me. So right? Applying that same idea here, this means that this is at most, right, n, right? Then the double sum, I is equals to 1, k not equals to j, n, and then this gives me what, 1 over m. Okay, now again we come back down to the idea of the distinct pairs, right? Each distinct pair, okay, is repeated twice, exactly twice, right? Okay, now think about it. Okay, I'm doing what kind of distinct pairs am I doing? I'm doing from 1 to n, right? Okay, and this is a constant. This is a constant, right? So this gives me 1 over m, I is equals to 1, and k not equals to j, and 1. Okay, with me so far? Erase this, erase this. Okay, great. Erase this. Done. Okay, now if I'm just counting the number of distinct pairs, right? The number of distinct pairs from n, right? What is that? You should know this from A-levels, I think, or like, you know, like combinations or whatever. If you don't, please go revise. So okay, so before I forget, right? Okay, so here's a note. Okay, if you don't understand any of the math, right, like why I did combinations or why these summation things work, please go revise CS1231. Okay, I'm very sure that the permutation combination thing, right, was covered in was covered in 1231, right? I know for a fact that expectation was covered in 1231. I know that some random variables, right, like what was it, geometric, I'm pretty sure, and the Bernoulli, right, are all covered in 1231, right? So please, if you don't understand any of this, right, in terms of like the combinations, like why this is n choose 2, right, stuff like that, or how expectation works, or random variables, please go revise 1231. Okay, because I can't really explain it. I mean, the video is really like 42 minutes long, so okay. Plus, you know, it's like assumed knowledge in this class. Okay, so let's move on. So I have that. I need the eraser. There you go. Okay, so since this is the number of distinct pairs, right? It's like n choose 2, right? N choose 2 times 2, right? Okay, I hope that part makes sense. Now that you have this, right, this is just the same. This is just the same as, what is this? N times n minus 1. Oh wait, so it's less than or equals to, right? N times n minus 1 over 2 times 2 and 1 over m. Okay, so this is the home run, right? If I have this, okay, so this cancels out, right? So now I have n times plus n times n minus 1 over 2. Okay, let me just move this up here. Okay, this, right, is less than or equal, so this is the same as, actually some of these are the same, right? Because if this is, okay, no, I'll just leave it as inequality because it doesn't make sense to change it now. So this would be the same as, let me get rid of this, there we go. This would be the same as n. I factorize it out, so 1 plus n minus 1. Oh, I forgot an n. I forgot an m. So this m goes in here, right? So m, there you go. Oh, no 2 anymore, right? So n times n minus 1 over m, right? Since I'm less than this, right? If I increase this guy, right? If I increase this guy, like if I add 1 here, right? This term increases, right? So therefore this thing increases, right? If I'm already less than this, I'm less than something larger than it, right? So I'm less than something larger than it. So I'm less than n over m, right? Right? So if I increase this guy goes larger, right? So this term on the right goes larger, right? So this thing goes bigger, right? So I mean, if you can compare, right? You can compare this guy and this guy, and you realize that this guy is bigger than this guy, right? Since what we were looking for, right? What was that again? Expectation of that summation thing. Since that was smaller than this, and this guy is bigger than this, right? So this guy must be smaller than this, okay? So this gives you n times 1 plus alpha, right? QED. Okay. Yeah. So I hope this was easy to follow. I'm pretty sure I could have simplified some steps, but I just really wanted to make sure that everyone could follow. So if this was too boring or too easy, I'm sorry. Yeah. Right. For the rest of you, I hope this was I hope this made sense. So yeah, thanks.